6 says, show that the following limit does not exist. Show that the limit as x approaches 0 of the absolute value of x over x does not exist. Okay, first thing we should do is find the value of the function by plugging in 0, right? So we're going to plug in absolute value of 0 over 0. Well, the absolute value of 0 is 0 over 0. So again, we get undefined. That doesn't help us. So if we don't know what the value is at our function, we're going to look at what's happening to the left of the function and the right of the function by our graphing calculator. So your whole lesson, all your homework, you're going to do it on your graphing calculator today. Okay? So y equals absolute value. How do we put absolute value in our calculator? Math button, right? Yep. Go to your math button. And it's not in the first menu, but if we arrow over to number, it's the very first option right there. ABS stands for absolute value. So absolute value of x, enter parentheses, divided by x. Okay. Usually an absolute value is like a, what kind of graph? A V, right? This one's not going to be a V though, because we're dividing by another x and that's going to change it. So let's press graph. And it looks like it's just a line, but actually there's more going on down here. So I want to move my window down into the negative section and to the left. So my window I'm going to change to let's make it -10. And then I need my Y, oops, I used the minus button. If you use the minus button, it'll give you an error. And then my Y value, my minimum, let's make it -10 as well. And then graph it. I get a line, and so I get two lines, two piecewise functions, and I get an open circle here and here. So, sorry. Okay, so this is what we get. We get at -1, we get a line, but then we get an open circle here, and then at +1, we have another open circle going to the right. Okay, because we know at 0, it's undefined both times. Okay, well, you know, so if we had our xy, our xy table, you know, and I put 0 in the middle, put 0 in the middle, and like, -1, -2, -3 here, +1, +2, +3 there. These would just be -1s, -1, -1, coming from the left. The value is -1. After I pass 0, I get an error at 0. And then once I pass 0, I get a bunch of 1s. So what's the limit? Is it -1 or is it +1? It's neither. Okay, so if your graph does two different things. From the left, it approaches one number, but then from the right, it approaches a different number, then this limit does not exist. So the limit does not exist. Okay, you can't do that. You can't approach from the left a different one and the right a different one, then it has no limit. Okay, and that's a good example of that. All right, example 7. A couple more examples. We're almost done. Let's look at example 7 here. Example 7 says, discuss the existence of the limit. Discuss the existence of the limit. The limit as the limit x approaches 0 of 1 over x squared. Okay. So first thing we do, right, we try and plug in 0 and see if we get a value. So 1 over 0 squared. Well, 1 over 0 squared, that's undefined because you can't divide by 0. So again, we have to look at the graph, we have to look at the xy table, we have to look at what's happening around 0, what's happening at like at a -1, at -2, at -3, so on, at 1, 2, 3. Okay, so let's put this in our graphing calculator. And let's do 1 divided by x squared, which is pretty easy to enter. matrix there, and then graph it. Ooh. Okay, so what I'm getting is a graph up there and a graph up there. Let me change my window. Let me get rid of the negatives because obviously we don't need any negative y's. So y, I'm going to get to 0 and then graph. It's a little nicer. It will zoom in a little bit. So what's happening at 0 from the left is you have an asymptote there, right? It's never going to cross 0 because we got undefined. When we plugged in 0, we got undefined. So there's actually an asymptote, and it goes up to infinity, and it goes to the right to infinity. So is there a point where those are going to meet? No. So since it goes on forever and it's unbounded, we said there's no limit there. That limit does not exist, okay? So let's just sketch our graph and show, oh, towards 0, it went up to infinity. Towards 0 from the other side, it also went to infinity. So this limit does not exist. Okay, it can't do that. It has to meet somewhere to have a limit. It can have a hole in it, but it can't just take off forever. So, and example 8 is an example of oscillating behavior. Oscillating behavior. That's when behavior goes back and forth, like your best friend, right? You go back and forth. One moment you're friends, another moment you're not, then you're friends, and then you're not. As x approaches 0, the sine of 1 over x. Okay, oscillating behavior. So we've introduced a sign in this function, okay? When we do sine of 1 over 0, I plug in 0 into here, I get sine of 1 over 0. I can't evaluate that because that's undefined. So I have to look at the function, what's happening around 0. So let's enter this in our calculator, okay? And I'm going to put sine of 1 over x. So sine of 1 divided by x. Okay, and then if I try to graph this, it's not really going to do anything unless I change it to radian mode. Okay, so let's go to, and then I need to change, I think, my window a little bit. Yeah, I need some negatives in here. So let me go back and put some, I'll go to -6 instead of that. And then I'll go to mode, and since there's a sign in, I definitely need to be in radian mode. And hopefully this will graph, because this is kind of hard to graph. Okay, did you see that? It was like a heartbeat. It went boop, boop, boop. But really, let's zoom in a little bit. Let's use our zoom in at 2 right there. And then the cursor is going to blink in the middle, and that's where I want it to zoom into, so I'm going to press enter. So that's really what the graph is, and maybe we could even zoom in more. So the graph is going up and down, it's bouncing up and down, and it's kind of irregular too. So this oscillating behavior, and then your book shows you like the values of, if you put your different x values in, what do we get? We get like +1, -1, +1, -1, +1, -1. So it's going up, down, and it's doing this thing really fast. Well, when you have oscillating behavior, there's no limit, okay, because it's just too irregular. So if that happens, no limit. Doesn't exist. Okay, so the limit does not exist here. And we could draw like a little graph of what it looked like. It went like down like this, then it went boop, 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 and then it went back like that. So because it's oscillating, limit does not exist. We use does not exist so much that we make an abbreviation for it. It's DNE. DNE. So if you want to write DNE on your homework, you can. We know that means it does not exist. Okay. And then the last part of the homework is just the properties. So take a look at those properties right there. I'm not going to, oh, I forgot to go over this. There are 3 times when limits do not exist. When f of x approaches a different number from the right side than from the left side. So, if one's part of the graph is coming down here, another part's coming up here, there's no limit. If it increases without bound as x approaches c, so if it takes off to infinity as it approaches c, then that's no limit. And then if it's oscillating, that's no limit. So those are the 3 cases when you have no limit, they do not exist. Okay. And then there's properties of limits. So your properties of limits, the limit as x approaches c of b is always going to be b, whatever b is. If that's 5, it's going to be 5. Okay. The limit as x approaches c of x, if you just have x, that's just a line. So whatever value you put in, if c is 5, then this x is going to be 5. If it's 8, then it's going to be 8. Okay? And then the limit as x approaches c of x to the nth is going to be c to the nth. So if this is, let's say 5, and you have x, let's say we have x to the 5th power, then it's going to be 5 to the 5th power will be your answer. And the limit as x approaches c of the nth root of x is going to be the nth root of c. So if this is as x approaches 5 of the square root, then it'll be the square root of 5 is your answer. Okay, which is pretty self-explanatory. The bottom part here, which I'm going to have trouble showing you, is if you have a scalar multiple, let's say you have like 5 times the function, and then you want to find the limit of that, well, you can just take, if f of x is, the limit of f of x is L, you can just take that scalar b, whatever scalar multiple you have, and multiply it by the limit of f of x. If you want to add two limits together, so let's say two functions together and then take their limit, well, let's call the limit of g of x k, right? Then you can just take the limit of this one and the limit of that one and add them together and do L plus k. If you want to multiply two functions and then take the limit, well, you could take the limit of f of x, L, and the limit of g of x, k, and multiply them. If you want to divide two functions and take the limit, you can just take the limit of f of x, L, and divide it by the limit of x, g of x, k. Okay, and then if you have f of x to the n and you want to take the limit of that, you could just take the limit of f of x, which is L, and raise it to the nth power. So these are just little properties that you can use for number 49 here. When you get to 49, you will use those properties. It's very easy. You can check the answers in the back and you'll see, oh, that's really easy to do. You just add them together. So, yeah, so you're going to do that. All right, I was going to do number 1 with you, and then we'll be done. Okay.